do this indefinitely long. MARR is 6%. Pick the best option. So you use the UAC to make your judgment. Okay, so we'll do A. Okay, so EUAC is going to be based on 7 years. Annual operating costs are $25,000. So UAC, whoops, look at the U. UAC. Yeah, I put it backwards. I'm off to a good start. Equals 25,000. And then the salvage is 50 at the end of year 7. So plus or minus salvage is income, so that's a minus 50,000, which is F times A over F, 6%, 7. And then plus 150,000 P times A over P, 6%, 7. So turning to the 6% table in the back, look up A over F and A over P for 7 periods. A over F is 1191 and A over P is 1791. Okay, and let's do it for machine B. This one's based on 8 years. So we have annual cost of 20,000. Salvage is 75. A over F, 6%, 8. And the initial cost is 175. A over P, 6%, 8. Okay, so we just read the next row down on the 6% table. A over F, A over P, 8 is 10, 10, and 16, 10. Okay, remember, we're calculating costs, so these are actually negative numbers, so we want less cost. So that's the best option. Now remember what's going on here. The reason that we can use 7 here and 8 here is because we have, for A on 7 years, 150, 150, 150 repeating, and at 7/14/21, the salvage value of 50. And then every year is 25,000. And then for 8, it would look a lot like that. The numbers would be different, but it would essentially look the same. 8, 16, 24. Infinity. With a cost of 175. And a salvage of 20. No, salvage of 75. And an annual cost of 20. Okay, that, because of that repeating pattern forever, that's what allows us to just do this one on 7 and this one on 8. Okay, but the third part of that question, or the second part is calculate PWC for the winning option. Okay, so that's B. So the present worth of the cost for B, because it's going on forever, we call that capitalized cost, equals A over I, equals, in this case, A is EUAC, and that's 40,600 over 0.06. So that's part A, this is part B. Before we do part C, what questions do you have about the rollover solution? Okay, let's do part C. Part C is, if the machine will only be used for 10 years, calculate EUAC. So now we're going to have a definite endpoint of 10. So, the first one is 150,000 at 0, and then 150,000 at 7. And a salvage at 7, 50,000. And then a salvage at 10. That's 3 years later, of 30,000. And an annual cost is still 25,000. Okay, so we have to approach this one differently because we have a definite endpoint and it's 10. So EUAC equals 25,000 plus 150K, the first one, P times A over P 6% 10. The second one, 150K. Remember, when you find the annual value, you have to start from 0 or n. Okay, so I'm just going to bring everything back to 0. Well, except for the 30, which is at 10. but I'm gonna bring that one back to 0. So 150K F times P over F, 6% 7, which brings it back to here, times A over P, 6% 10. And actually, rather than deal with this and this separately, because they're at the same point in time, I can do 150 minus 50. Does anybody not see why I just said that? Instead of adding another element to my solution for the plus 50, I just do 150 minus 150 plus 50. And put 100 right there. Okay, and then the 30 minus 30K F times A over F, 6% 10. Okay. So we need P over F, 6% 7, 6651. A over P, 6% 10, 1359. And A over F, 6% 10, which is 0759. Okay, and for option B, lasts for 8 years and costs 175. That's the salvage at the end of year 8 is 75,000. The salvage after 2 years is, I should have put something higher there. That didn't make a lot of sense. Okay, well, we'll just roll with it. I should have put like 150 instead of 50, but we'll just roll with 50. And then every year is 20,000. Okay, so UAC is 20,000 plus 175K times A over P, 6%, 10, which we know is 1359 because we just looked it up. Okay, and then here we've got 175 minus 75 is 100. It's F times P over F, 6%, 8, because it occurs at 8 instead of 7, times A over P, 6%, 10, and then the final salvage of 50 times A over F, 6%, 10. Okay, we already know that one too. We looked it up. It's 0759. So we need to look up P over F 6% 8. P over F 8 is 6274. So we take 20,000 plus 175 times 1359. Plus 100 times 6274 times 1359 minus 50 times 0759. It's 48,515. Now, the reason the second one is so much higher was because I should have put 150,000 right there, not 50,000. So it would have been, we would have subtracted, if that was 150, we would have had an additional 100,000 times 0.07, so 7,500 bucks. We would have subtracted 7,500 more. It still would have been higher, would have been 40 versus 27. But machine A is cheaper on a 10-year, and on a repeating, machine B is cheaper. Questions about that? Go ahead.
Should we just put best option next to it?
Yeah, that's fine.
To signify which one.
Yeah. Yeah, like that. Okay, so actually, though, I did the same thing here, didn't I? I should have put something significantly higher on that one as well. It doesn't make sense to sell it for 50 when it's 7 years old and 30 when it's 3 years old. Anyway, those two numbers should have been higher. But just solving it with what's on the table, that's the answer. Okay. Problem 2. Assume you're going to purchase a house for $450,000. Down payment is $90,000. Interest rate is 6%. Monthly compounding of payments. Okay, 30-year loan. Calculate the payment. Okay, well, payment equals A equals the loan amount is P equals 450 minus 90. Okay, so we have 360,000 for P times A over P is 6% with monthly payment and compounding. So I equals 6% over 12 equals 0.5%. Okay, so 1.5% for 360 periods. %, A over P all the way down to 360 is 0.00600. It's 2160. Questions about part A? Okay, part B. Does anybody remember how far, I don't remember how far back that was, 2 or 3 weeks ago when we talked about this. Calculate the payoff amount for the loan after 10 years. How do you figure that out? You could build a table, you'd be there all day, right? But unless you have Excel, then it would take a few minutes, but there's a quick way. Nobody remembers. This is the present value of the remaining payments. Okay, so A equals 2160, which we just solved. Remaining N equals 240. Because it's a 360-month loan, we've already paid the first 120. So there's 240 more to go. Okay, so payoff equals P for the remaining payments. Equals A 2160 times P over A 1/2% 240. One half percent P over A 240 is 139.581. It's kind of depressing to think about. 10 years of payments, 120 times 2160. It's $259,000, and you paid off $59,000. Go ahead.
Aren't those payments also in the future though? Because that's 120 payments out from now. You're asking for them to value of the remaining 240. Don't you have to bring them back from the future as well to get the actual present value?
Well, no, because we're doing A times P over A, so we're finding it at 0. If we did A times F over A, then, yeah, then we'd have to bring it back 240, but that would be extra work.